What's up guys, welcome back to a brand new academic learning video, and in this video we are going to be covering absolute value inequalities. So let's go over the basics first. So when we have the absolute value of x, what we know is that that either means that x is going to be positive every time you plug in any number from this, or just zero, so positive or zero. So if we have something like the absolute value of x is greater than 3, what that means is if we have the number line here, you have 0, 1, 2, 3, minus 1, minus 2, minus 3. So for the absolute value of x to be greater than 3, think about it like this. Well, anything 3 and above will be greater than 3. So we can shade in this part of the graph. Well, why? Well, the absolute value of 4 is obviously greater than 3. The absolute value of 6 is obviously greater than 3. Now, the reason there's an open circle here is because the absolute value of 3 is not technically greater than 3. If it was greater than or equal to, it would be a closed circle. But greater than, we still have to keep it an open circle. Now, if we have something less than 3 but greater than 0, it's not going to satisfy it. For example, the absolute value of 1 is not greater than 3. But when we get to the negative numbers, it starts to become a little more interesting. Now, -1, absolute value of -1 is +1, so that won't work. But let's say we take the absolute value of -4. The absolute value of -4 is +4, which is greater than 3. So what we see is that there's actually two regions. So this is a compound inequality. One is that it's either greater than 3, so x greater than 3, or it's less than -3. And if you think about absolute value as a distance, this makes sense. You're saying that the distance from 0 is greater than 3. So you look at the distance on either side to see if it's greater than 0. Greater than 3. So that's cool. So we know that the absolute value of x means that x is greater than 3, or x is less than -3. But we can generalize this. If we say the absolute value of x is greater than a, what that really means is that x is greater than a, or x is less than -a. Now, I hope that's pretty clear to see from this example, but if it's not, please leave a comment down below and I will answer it. Okay, so that's the greater than case. Let's look at the less than case. So here we have the absolute value of x is less than 3. Now, from the greater than case, we know that the greater than case was you take this, shade it to the right, take this, shade it to the left. And you know that the absolute value of x less than 3 and the absolute value of x greater than 3, they're going to be opposites of each other. Technically, there is one point. No, actually, there's no point where they're in common. If it was greater than or equal to, then they would share the 3 as a common point. But in this case, there's no point where they're in common. So they're actually just exact opposites of each other. So because we know they're exact opposites, we simply shade in all the areas that this didn't cover. So let's look at this. If we have the absolute value of x greater than 3, it goes 3 to the right and -3 to the left. Now, 3 to the right and -3 to the left, they're shaded. So the absolute value of x less than 3, it's not going to be shaded. Because let's say it was shaded, well, then we would have points that are both greater than 3 and less than 3, which is just not possible. But on the points where absolute value of x is greater than 3 is not shaded, then we know that the absolute value of x less than 3 is shaded. Why? Well, you're given, hey, the absolute value of x is not greater than 3, so it's got to be less than 3. Technically it could be equal to 3, but for our case, we just put an open circle here, and then for every other point, it should be considered the same. So to go over that one more time, you're basically saying, hey, where's the absolute value of x greater than 3? And wherever the absolute value of x is not greater than 3, it's probably going to be less than 3. So that's how you can get this graph. There's also a few other ways to see it. One is you could just plug in the points and say, hey, these all make sense because once you go above here, then the distance from 0 is going to be greater than 3. And another way is just looking at the distance again. You're saying the distance from 0 is going to be less than 3. So we're going to be within 3 of the origin. So what we can conclude from this is that the absolute value of x less than a means that x is between negative a and a. Another way to write this is that x is both greater than negative a and x is less than positive a. So if we have a graph 0, a, minus a, x is both greater than minus a, so x is got to be greater than minus a, and x is less than positive a. So that's positive a. So where they overlap is going to be our and section. So this will be the solution, which is also just between negative a and positive a. So that's just the basic heuristics for solving absolute value equations. Now, the truth is, these are just shortcuts. The real method to solve inequalities is to use something where first you find the boundary values. So let's say we have boundary here. So in this case, absolute value of x, let's say greater than 3. The boundary would be 3. And what the boundary values are the points where they're equal to each other. So actually it would be 3 and negative 3. And then you test each region. And if the region satisfies the inequality, you shade it. If it doesn't, you don't shade it. And of course, if it's greater than, you put an open circle. If it's greater than or equal to, you put a closed circle. Now, I'll probably cover this more in detail in a later video, but just to give you a rough idea of why this works, basically, this inequality can only be true or false. It can't be anywhere in between. But when we test a value, let's say it's false. Well, we test more values. The values around that are probably going to be false also. So when is it going to switch to true? Well, the only place it could switch to being true from false or false from true is the boundary values. So that's why you test each region around the boundary values, because this region has the same truth value. It's either true or false. This region has the same truth value. It's either true or false. This region has the same truth value. It's either true or false. Because if it had different truth values, then there would be a crossing over, and crossing over means you have to have a boundary value here. I hope that makes sense. If not, I'll probably make another video on it, or just leave a comment and I'll probably answer it. Okay, so now let's do some harder problems. If we have something like the absolute value of x minus 1 plus the absolute value of x plus 2 is less than or equal to 4, let's go ahead and solve this. Now, at first this seems a little daunting. Like, how am I supposed to solve this with just the standard rules? That's only for one absolute value. I have two absolute values here. Well, here's how you're going to do it. First, you're going to isolate one absolute value. So you can isolate the absolute value of x plus 2. And here you move the other absolute value to the other side. Now here, this right here, what this really is, it's just a variable. So we can call it a. Now, this might seem familiar. Let's call this y. This might seem familiar. This is just the standard rule we learned earlier. So if you have the absolute value of y less than or equal to a, what we know is that is minus a is in between. Actually, it's going to be equal to sign because the equal to sign is here. And y is between minus a and positive a. Now, if that doesn't make sense, go ahead and review the video. Now, here we can apply it. Instead of a and minus a, we have this is a and this is y. So what we can actually do here is put these variables in place of this to make the equation simplified, or to solve the equation, or inequality, sorry. So we plug in a, then we plug in y. Sorry, y is just x plus 2, not absolute value of x plus 2. And then we plug in a again. Now let's think about what we just did here. We came up with the rule earlier. The absolute value of y less than or equal to a means that y is in between minus a and positive a. Now, in this equation, it doesn't look like we can apply that rule at all. But remember, these equations don't just work on individual letters. Variables can be anything you want. So we can replace each of these terms as variables. So one thing you have to learn how to do is to see equations in things. If you're only given a set of tools, you have to be able to apply those tools very creatively. Now, if you have a lot of tools, this becomes a lot harder because you're like, which tool do I use? But in this case, our tool set is very limited. And I'm assuming if you have like a test or a quiz, your tool set is also going to be limited. It's just going to be the formulas in the book. So you're going to have to come up with very creative ways to apply those. Okay, so let's do a bit of simplifying here. We can distribute the negative, and that is pretty much all we can do to simplify. So here, I'm just going to split it up into two different equations just to make it a little bit more simple. So we have this equation, and we have this equation. And if you're not sure where we got these, well, basically it has to satisfy both this equation, so I just literally just copied it down, and it has to satisfy this equation, so I literally just copied it down. And that's why the and is here, because it has to satisfy both. If they're in one statement, they have to satisfy both. So here we can work on these individually. Let's just work on this one to the left first. So we have the absolute value of this plus minus 4. So we can add 4 to both sides. Here we can use the rule we learned again. Remember, we can treat this as one variable, this side as one variable, and this side as another variable. So if this case is less than or equal to, so we have x plus 6 less than or equal to x minus 1, less than or equal to, actually this should be a negative here, x plus 6. Let's do a bit of simplifying. Actually, I think it's in my best interest to just split this up. So we can do that. And again, that's just literally just copying them down both. So we can distribute this to get minus x minus 6 less than or equal to x minus 1. We can add the x and add the 1. So minus 5. In this case, we get x minus 5 halves less than or equal to x, or we can just rewrite this as x greater than or equal to minus 5 halves. In this case, if minus 5 halves is less than or equal to x, you know that x is greater than or equal to minus 5 halves. Now let's work on this right side. Here, actually looks pretty simple, right? We can subtract x from both sides to get minus 1 less than or equal to 6. And this will simply be all real numbers. So in this case, if we're looking at the conjunction between, well, x greater than or equal to minus 5 halves, that's simply just, you start at minus 5 halves, goes to infinity. This is just interval notation. If you don't know this, then I might make a quick video on it, but really all it takes is a Google search and you should be pretty fine. And all real numbers is minus infinity to infinity. So, sorry, it's not the union, it's the intersection. And means intersection. So this is the symbol for intersection. It's just an upside down U. So if we want to intersect these two terms, well, let's consider what that means. It means you have minus 5 halves. Actually, I'll write this below. So let's erase this on top. So minus 5 halves, and we go to the right. And the second term is just all real numbers. So where they intersect is just this right here. Well, why? Well, only one, if we go to the left of here, only one of them satisfies, which is all real numbers. But if we go to right, then both of them satisfy. So here, the answer for this side of the inequality is just going to be this right here. But remember, we still have a second side of the inequality, which is this. Here we do the exact same process. I'm going to bring this absolute value to the left-hand side to make it a little bit easier. So this is plus x plus 2 and 4. Now I'm going to subtract 2 from both sides and subtract x from both sides. Actually, yeah, so minus x plus 2. X minus 1. Here we can go ahead and do the absolute value tool that we used. Remember, this is just a variable and this is just a variable. So we can use the formula. I don't really like using the word formulas because it's really just, it should be just a proof that you use, but in this case, let's just use this tool. So we can write this. Actually, I'm just going to split it up beforehand because we're going to split it up anyway. So this is both less than or equal to minus x plus 2, and it's greater than or equal to the negative of minus x plus 2. That's a bit weird. Okay, so we can add the x and add the 1. So add the 1, 3. So x less than or equal to 3 over 2, and let's see, x minus 1 greater than or equal to, minus and minus will cancel to give us x, minus and plus 2 will give us minus 2. So here we can cancel out both x's to get minus 1 greater than minus 2. That's true, so it's true for all real numbers. And again, if we want this and that, it's simply just going to be the less strict one. So if you have the intersection of any interval and all real numbers, the intersection is just going to be that interval. If you have a question on this, leave it in the comments. So this is going to be the answer for the right-hand side. Okay, so let's recap. We have one answer for the left-hand side and one answer from the right-hand side. Let's scroll up. What we wanted is the intersection. We want where they both are true. So let's graph them. So we have our two boundary values are minus 5 halves and 3 halves. So you have x greater than or equal to minus 5 halves, which is going to be here to the right. We also have x less than or equal to 3 halves, which is going to be here to the left. And if we want where they intersect, it's simply just going to be this region right here. So x must be in between minus 5 over 2 and 3 over 2. That is our final answer. Another way you could write this is minus 5 over 2, comma, 3 over 2. All right, that's going to be the end of this video. If you have any questions, please leave them in the comment down below. And one additional challenge for you is, you know that boundary value method I mentioned earlier of solving inequalities? Try to see if you can use that to solve this inequality. And yeah, I'll see you in the next video. Bye.